Here we go. Let's talk about virtualization. We'll cut out all that other stuff, right? So virtualization essentially is everywhere. Has anybody had a chance to use like the VR headsets that have been out?
Yes.
Yes. Anybody else? A couple people? If you ever get a chance, it is incredible. It's the kind of thing that you can hear described to you and it's just like, oh, whatever. But then when you actually get into one of the headsets and you're in that world, it is unbelievable.
Do the 2005 racing simulator things count? That you put you put those on, you got a steering wheel?
Yeah, okay.
Does that kind of count?
You look in all directions
It's
and
very
see things.
16-bit, but still.
Well, okay. So that
2005 was a great.
that is that's kind of a virtual world, a virtual reality kind of thing. Augmented reality is putting things on top of your reality, augmenting or changing your reality. But one of the way that we're talking about it in the networking sense is virtualizing a piece of machinery. So let me be able to run things without having physical pieces of machinery to do it on. So here's a video about that. Instead of me going through 15 slides, here's someone else talking for a minute.
Something a little more fantastical. The concept of virtual reality is still a little ways away from completely fooling our brains into thinking we're actually in Middle Earth or whatever. But for your computer, it's pretty simple to fool it into thinking that a fake virtual environment is the real deal. I'm talking, of course, about virtualization, which has become a really useful tool for home users and IT pros alike. But what the heck is it? Well, in a general sense, it means putting layers of software between your computer's hardware and some other software that you're trying to run. But more commonly, it means running one operating system on top of another one, on top of another one, on top of another section. No, usually it's one layer and then more operating systems. So you've probably seen this in the form of running one version of Windows as a virtual machine or a VM inside a window in a newer version. This has all sorts of real-world applications, but before we get into this, it helps to understand something about how your computer achieves this. You see, your computer grants different pieces of software different privileges depending on what they are. Your operating system has a lot more privileges than regular programs, like being able to directly access hardware like your memory or your CPU. The idea being to stop malicious applications from attacking your system or crashing it. Because of this, early virtualization software that was forced to run as a regular program without privileged access to hardware directly had to translate the actual instruction set of the processor, which you can learn about here, by the way, so that the virtual OS could actually make any use of it. Or as an alternative, you can install a small program called a hypervisor as the main OS on the computer, then virtualize your main OS, like Linux or Windows or whatever else, on top of that to actually run programs. But because of the overhead involved with translating instructions, this resulted in some serious slowdowns in terms of performance. But in the mid-2000s, both AMD and Intel started making processors that natively supported virtual machines, allowing a hypervisor to run below the layer where an OS would usually be, which means that the system wouldn't have to spend time translating instructions, enabling much faster, near-native performance. Okay, Linus, so that's a lot of technical talk about hypervisors and layers and onions or whatever else, but what does that mean for me? Can I actually use this stuff well? Yeah, actually. If you have older games you still love that just won't play nicely on your modern 64-bit operating system, you can run an old 32-bit version of Windows in a virtual machine and play to your heart's content. Cool, right? VMs are also useful for testing new software, or even like a website that you're not sure whether it contains malware or not, because you can just delete the entire virtual machine without touching any of the important data on your main OS or even your network if you quarantine it effectively. And speaking of your main operating system, if you're thinking about switching to something else completely different, you can actually try your new OS in a virtual machine without nuking your existing hard drive and your existing OS. Not to mention compatibility between operating systems. Remember parallels that I mentioned before? Windows applications on the Mac? That's right. And if you have important data that you can't lose, VMs are also a very easy way to back up. Most VM software can take snapshots of the entire virtual system at a given point in time, kind of like an Uber system restore. This capability has made it very popular on servers, which often need redundancy and backups to ensure constant operation, not to mention the fact that running multiple virtual machines on one server can put all of that processing power to better use, as modern server hardware is notoriously underutilized, especially if the workloads don't natively take advantage of many processing threads at a time. But if you want to do something really cool, you can virtualize your gaming rig and turn one beastly PC into 3 virtual machines, a NAS, and then 2 gaming boxes that 2 players can use at once. So you can check out this video for a practical demonstration of how it's done and the results. Speaking of practical, you know what's practical?
Okay, there were commercials on. So that's just a little bit about virtualization and the things that can be done with it. The virtual world, when they talk about that kind of stuff, they normally bring up Second Life. If you've ever played that game, it's quite popular. I think it's still around.
Yeah.
Still around. At one point, TSTC taught an entire degree in Second Life.
Does that explain why there's like pictures of it in the admin building?
Yes.
I was curious.
I always
about
wondered that too.
Okay.
Why is all this up here? That's why. It's because there was actually a degree. You could go in a virtual classroom in Second Life and earn a degree.
Why did they get rid of it?
I don't know. I don't remember what it was in.
Do my class and not jump.
I know. So, way back, the first things that we talked about in terms of virtual machines, we had the dumb terminal. So we had a keyboard, we had a display. We didn't have mouses back then. We had a keyboard, and we had something that was a display, and it was probably this big and really hard to read. That was hooked up to a mainframe, and that's what we interfaced with to be able to use the mainframe. Terminal services was the hypervisor used to connect to a terminal client, so that's what we used in Windows, terminal services. Since then, they've changed the name a little bit, and of course the client is involved as well. So in today's virtual desktops, we've got the thin client, which is just a desktop with very little power, very little peripherals to it, that's designed just to connect to a server. All the stuff is on the server, and you're just logging in and connecting to your stuff on the server. In some cases, in real extreme cases, this comes in the form of like one little bitty USB thing that you can plug into a monitor, and you connect with your Bluetooth with your mouse and your keyboard, and it's all self-contained, and if the little thingy breaks, they bring you another one and you dial in and you keep working. So that's an efficient use of that. There's a host OS, there's the guest OS, and you can switch between the host OS, which is the one that's installed on your PC, and the guest OS, which is whatever thing is being virtualized, whatever software that is. And that gives us the virtual desktop infrastructure. Again, in today's virtual desktops, the hypervisor is the program that allows you to have the virtual machines. In this class, we're going to use 2 hypervisors. We're going to use VMware Player, which you can see VMware is on this list. We're also going to use Oracle VM VirtualBox. So a lot of branding is used within these terms, but these are some of the things that you might see. The difference between Type 1 and Type 2, Type 1 runs directly on the computer without a host OS, so it's kind of like a DOS environment. This is the closest thing that I can put that to, and then a Type 2 needs to have a host OS on it to install that. So we have our host OS on the computers in here is what? What do all these computers contain? Windows 7, right? So Windows 7 is our host. And we're going to be using Windows 8.1, Windows 10, and Ubuntu Linux as our guest OSs on that computer. And all the Linux nerds rejoice. All one of them. Yes.
Why are we still on 7? That's the big question.
Because it's better than the other OSs.
The official answer for that is that the proper way to upgrade software is not to upgrade and then, hey, let's see what happens. It's to actually determine if all of TSTC's processes and all the software that we use are compatible with Windows 10. Test it, then implement it, and then audit that test.
My next question is, why do we not just go with Linux?
Because it's not user-friendly, and people who are been using Windows their entire lives don't know what to do with Linux, myself included.
That's why we're here to learn.
Yes. Yes, this is true.
We should learn on Linux. Learn on the hard stuff so we know how to use it on
We
the
will
easy
get to
stuff.
Linux, we will get to Linux, we will get to Ubuntu. So for example, this is OS 10, so this is an Apple operating system, which has a window inside of it, which is a virtual machine of Windows 7. So you can do that way, but you can't flip it. You can't do it the other way. We can't run Apple operating systems on these Windows 7 computers. We'll talk about why when we get there. But when you want to create a virtual machine, you've got some things to do, but not too many. You want to prepare the host computer. So basically make sure it's not something that's super important part of production. Because if you install a VM and mess it up, you don't want it to mess up the computer. That's simple enough. Make sure it has all the right specs to make sure that it can handle the load that you're putting on it. Don't try to run 2 hypervisors at once. It's kind of like running 2 antiviruses at once. They're going to fight over resources, and eventually they're all going to crash. You want to install the hypervisor, which is again the program that you're going to install VMs into. Create that VM, install the guest host with what we call an ISO file. So I'm going to give you, for example, next week we'll talk about Windows 7. I'm going to give you an ISO file, and that ISO file contains Windows 7. You're going to make a virtual machine, pull it up, and install it just like you were putting a CD in the computer, but obviously it's virtual, there's no CD, right? But the ISO is our way of doing that. We're going to install guest utilities and security things if we need to. Depends on the hypervisor whether we need it or not. And then we're going to locate the host key. So the host key is the way that you move between the operating system on your computer and the operating system that is virtualized. So in VMware, that's Control-G. So you're clicking around inside the Windows 8.1 that you have put in a VM, and you want to go back to your Windows 7, you hold down Control and hit G, and then suddenly you're back in your operating system. So it has to be able to understand which one are you focusing on right now, the one that's actually on your computer or the virtual one. Some of those big sources, again, for hypervisors are Citrix, VMware, Parallels, Microsoft, and Oracle. For every one of those, there are a whole slew of certs you can get. You can get certified in VMware. You can get certified in Citrix and add some zeros to your paycheck.
Hey.
The virtual desktops, they just install like any other program does. It's actually really, really easy to do. Here's an example of VirtualBox, just going through a plain setup wizard, like anything else would. So, as far as virtualization occurring already on Windows desktops, we have Windows XP mode and Windows Virtual PC already on Windows 7. So there's different instances for when we would use those. Now I will tell you that I have experienced that Windows XP mode is no longer supported, but what it was for was used to run legacy applications. So let's say you have a line of business application. That means an application that your business needs to run. So let's say you're a machining business. This is the program that works with the machine that you use to create whatever, widgets, right? We always use widgets. And that cannot go down, right? So in order for you to purchase new software, somebody would have to build it and it would cost you like a whole bunch of money, tens of thousands of dollars. So you need to upgrade your computer. Well, you just run that in Windows XP mode. You fool the computer into thinking it's using Windows XP even though it's not. And that was very commonly done for legacy applications. There's lots of industries that still run on Windows XP. When that computer dies, they have to run their software in Windows XP mode, so it still works. That's actually a pretty common occurrence. And Microsoft, here's Windows Virtual PC as well. Those are already part of Windows components that you can install and use. And there it is in the turn Windows features on and off. We'll talk more about that in the next chapter. But it is just part of Windows. In Windows Virtual PC, you can put Windows Vista, Windows 2000, and even Linux, so that you can be able to work virtually without installing some other program, like we're going to do in class.
So say you had like a game that was optimized for Windows 7,
Okay.
but if you try to run it on Windows 10, there's a massive compatibility error. You run the Windows 7 in the VM, you can properly run that game?
Yes.
That's going to fix a big problem.
Yes. That, or you could right-click on the executable for the game, go to Properties, and then go to the Compatibility tab and set it as though it is in Windows 7. Either way,
Okay.
you'll do the same. Actually, the second way is probably a little easier, but either way could work.
Doesn't
Yeah.
talk about Fallout 3.
It's the same thing. That's what I do.
So this is what we call hardware-assisted virtualization. You can download that from the Microsoft website, but it is, again, something that comes with Windows. If you wanted to go look at it, to the Download Center, you can simply download that. Since we all have Windows 7, we're going to do that in class as well. If you want to remove it, you just go and act like it's a program that's installed on the computer. Remove it. Simple enough. The same for Windows Virtual PC. So those just show up as Windows updates. And you can always go to a Windows update you don't want, right-click it and say uninstall, and that will do that for you. Hyper-V is the Microsoft branded version of virtualization. It is a Type 1 hypervisor. There's no XP mode or anything like that. It only comes in the more expensive versions of Windows. It doesn't come in the home versions. But it requires quite a bit of the computer to be able to run, including 4 gigs of RAM, which isn't that big of a deal, right? Most of us probably have that. But it also requires a CPU with SLAT enabled. I looked up the definition of SLAT because the textbook didn't really go into it. Let me just tell you, it has something to do with the paging file. Other than that, we're not getting into it. Because it, several paragraphs. But the point being that Hyper-V is a little more intensive on your hardware. If you want to enable Hyper-V, same thing. Make sure that it's supported. Go enable it in your Windows features. It's got a nice little GUI with it. Then you can manage all your VMs, and it looks a little bit like this. So it is just another part of Windows since it's Microsoft based. If you want to create a virtual machine, you can go over this Actions menu, just say New Virtual Machine. And then it will start going through this wizard asking you what do you want to call it, what's the operating system going to be on it, and you can get that started. The Hyper-V Manager, you can create a virtual switch. So essentially you can make VMs, even though they're kind of their own self-contained things, you can make them talk to each other. And I have some classes where we do that, but you can make a virtual switch and then connect these virtually. So you have a virtual network and a virtual switch. You can, again, remove that through Control Panel because it's just a feature of Windows. What we're going to be using in class is Oracle VirtualBox. So this is a little bit older program, but it runs quite a bit of things on it. You don't have to have a specific processor that's got virtualization enabled to be able to use it. It's just there. So virtualbox.org is where we're going to go to get that when we do our lab this week. On OS 10, we have Apple Boot Camp. So Boot Camp allows us to dual boot. So when you're starting up the computer, you get to choose, do you want to go to the OS 10 environment or do you want to go to Windows 7? because some things are only compatible with one or the other, that might be a good idea. For example, in my Fundamentals of Networking class, we discovered that Packet Tracer, the Cisco simulating software, does not work on a Mac. Never has, never will. For some reason, they just don't want to make it. So if they would, if a student wants to do this dual boot, they could just go into Windows 7 and use it like anything else. But that is available for OS 10, 10.6 or later. You have to have a keyboard, you have to have a mouse, and you've got to have some kind of optical drive for that to work. But that is a great dual boot option. You can run all different kinds of versions of Windows in it, or you can again boot into OS 10. And that is just an application. It's going to create a new partition to put the operating system on. So it's going to divide the hard drive up and say, this part belongs to Apple, this part belongs to Windows, so that they don't cross. And you can install from the ISO file like we're going to do. And here's what Boot Camp looks like. The Boot Camp Assistant is what gets you going so you can dual boot. On Oracle VirtualBox, you can use, for OS 10, you can use Windows, Linux, or even boot to DOS. VirtualBox is about the same again, a little older. You can still create VMs on it. You can still make them talk to each other. You will notice something called guest editions. So one of the things when I was going through trying to make Ubuntu work on VirtualBox, which is apparently impossible, there was something called guest editions that needed to be added that made some changes to the way the virtualization occurred to make it more usable. So that guest editions is something that's specific to VirtualBox that you might come across. But again, here is Windows 10 running in a VirtualBox on host computer, which is OS 10. And here's the download page to go to get VirtualBox that we will be using in class. So the main thing I want y'all to get out of this is, why would we want to virtualize something? Maybe we can't run software because it's the wrong operating system or the wrong edition of some sort. A lot of times this is used for testing purposes. So like we were talking about, why haven't we moved to Windows 10 yet as TSTC? Well, there are people in IT who have Windows 10 VMs and they're trying to run all the applications that TSTC uses to make sure that there's no compatibility issues. And if there are, well, they've got to figure out how to get around those. So that kind of testing and stuff is one of the really big reasons that we would want to use virtualization. And another big one, of course, is if you just want to try out another operating system, like the video said. If you decide, hey, I want to look at Windows 10 before I upgrade to it, let me put it in a window and play with it and see what's different. That's another reason you might want to virtualize. So virtualization is, to sound completely corny, is the future of computing. Having physical boxes is not going to be the way things always are. That's what we're used to. But eventually everything will be on the internet and everything will be on a server somewhere else. That's my belief anyway.